Welcome to this tutorial on random shuffle in NumPy. Today we'll master the np.random.shuffle function, which allows you to shuffle arrays in place. This is a powerful tool for randomizing your data directly without creating copies. The np.random.shuffle function randomly shuffles the elements of an array in place. The key feature here is that it modifies the original array directly, rather than creating a new shuffled copy. This function returns none because it operates in place, meaning your original array is permanently changed after calling this function. The syntax is straightforward. First, you import NumPy as np, then you call np.random.shuffle, passing your array as the argument. Remember, this will modify your array directly, so make sure you want to change the original data. Let's see a practical example with a one-dimensional array. We create an array containing the numbers 1 through 5. We print the array before shuffling to see the original order. Then we call np.random.shuffle on our array. Finally, we print it again to see the shuffled result. Notice how the original array itself has been modified. Here's what the output looks like. Before shuffling, our array is in order: 1, 2, 3, 4, 5. After calling shuffle, the elements are randomly rearranged. In this example, we get 3, 5, 1, 4, 2. Your output will be different each time you run the code because the shuffling is random. Now let's explore how shuffle works with multi-dimensional arrays. We create a two-dimensional array with 3 rows and 2 columns. We print it before shuffling. Then we apply np.random.shuffle and print the result. Something important happens here that you need to understand. When shuffling multi-dimensional arrays, the function only shuffles along the first axis. For a two-dimensional array, this means entire rows are shuffled, but the elements within each row stay intact in their original positions. The rows themselves are rearranged, but each row maintains its internal structure. Also remember, the function returns none, so you cannot assign its result to a variable. Let's summarize the key points. First, shuffle is an in-place operation, meaning the original array is modified directly. Second, it's fast and efficient because there's no memory overhead from copying data. Third, it only shuffles along the first axis. If you need a shuffled copy instead of modifying the original, use np.random.permutation instead. Now you're ready to use shuffle in your own projects.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.